All right, cool. So this is our third edition, and we started again doing this meetup because we thought that as a big group of DevOps engineers here in Barcelona, it's not fair that we don't have a proper meetup for us. Okay, so welcome. I'm going to introduce the organizers or the common organizers that we have here. And the first one will be Esther, ladies first. David Acacio, I don't know if you know him, so you can find all of us on LinkedIn as well. Feel free to reach us. Ring Grau, this guy. Enric Font, the guy downstairs in reception helping us with all the access cards. Myself, David Castañeda, and Adevinta. As you know here, you're here in the office, so they are providing us with this space and giving us some snacks and drinks. So there you go. This is us, and I hope you enjoy the event. Now, I think Ferran is going to present or say some words about Adevinta.
Only a little bit, because probably the great part of you know it. We always present Adevinta because in Spain, especially, when we talk about Adevinta, nobody knows about what company it is. But when you say that behind Adevinta there is InfoJobs, there is Mil Anuncios, or there is brands, usually people start saying, oh, because the people know by the brands. We always say that we are a multi-company because we have a lot of brands spread by Europe and a lot of countries, so in Canada, in the different ones. And for example, we have Leonqua, that is a big marketplace in France, and lots of them. And we are always open and always happy to have meetups, and we are welcome to every one of you to join us. So only a little bit of presentation for this. So now,
Thank you. Now we're going to go and proceed with our first talk.
All right. This is why I came 20 minutes early, to rehearse that everything was working properly. And as you can see, that worked out. Where's the laptop? There you go. All right. I thought this was a great afternoon to come and talk about infrastructure, given that half of the internet is down or has been down thanks to our friends at Facebook. So let's infrastructure. I'm going to talk today about growing pains based on some of my experiences in the past, loosely based on some of my experiences in the past, because you might encounter yourself with the need of growing and scaling an infrastructure team. And today, I'm not going to talk about technology per se. I'm going to talk about the important parts of technology, which is decisions, communication, and all these things that we sometimes overlook. So first of all, I would like to start by saying thank you to Adevinta and to the organizers, especially to David Acacio, who convinced me to speak in public after a few years of not doing so. I would like to start by saying that right-sizing an infrastructure team is a very hard problem. It's a problem that many of you have encountered, and many of you have encountered in subtle ways. When things don't work for seemingly technical reasons, it might be just a problem of size of a team or a problem of how you work, obviously. That being said, I think there's something that's even more difficult, which is making the right infrastructure investments at the right moment. I think that that's an impossible problem. All decisions that you make in technology and infrastructure are based on things you know today, are based on things you think you know today, and are based on things that you think will happen tomorrow. Hence, the likelihood of getting it right is pretty low. So I have prepared a story in 8 chapters, mostly tracking from like small problems to bigger problems, roughly mapping my experience over the last 25 years working in technology teams. And let me tell you a bit about myself first. So I do 3 things nowadays. One of them, I co-host a podcast in Catalan called 2048 enllà, alongside Oscar, who's there. We talk about technology in plain English, but technology problems that go a bit deeper than the usual technology type of problems. We felt that there was a bit of a gap in Catalan, and we thought that this was a good opportunity to do so. We started in September, and we still have some energy to record an episode a week, so subscribe. As of 1 year ago, more or less, David, Ignasi, Eduardo, who is not here, Javi, who is here, invited me to join as a host in their now 10-year-old podcast about DevOps called Entre DevOps. I invite you to subscribe as well. Someone commented in the chat we have that, oh, I discovered this podcast. I saw it was 10 years old. I assumed that it would be dead. Well, it's not dead. We still publish every month. And I'm having a lot of fun with them. And this is something I started very recently, as of like 4 days ago. But I'll tell you more about that later. So my CV. Thanks to Ignasi and Xavi, I don't know where you are, there. I got acquainted with this world of Linux in 1998. For me, it opened a bunch of possibilities. I was like a technologist, so to say, when I was a teenager, but I had not discovered this side of the world, and I thank them for everything that they teach me. Few years later, thanks to Alberto Horta, who is not here today because he's not a very social person, I started an ISP in the middle of the dot-com crisis. Exactly in 2001, when everything was shutting down, we started an ISP with 83,000 pesetas, which was what we had in the bank, and we survived for 7 years. So pretty okay. We were pretty tired after a while. After that, I led some infrastructure departments in several companies in Barcelona. One of them, one of the international branches of InfoJobs, named Charisma. So I have some connections with Adevinta, very ancient ones perhaps, but good connections with Adevinta. But I wanted to learn the ropes of higher up management. Honestly, I wanted to be a programmer. I wanted to manage my servers. I wanted to log into my console and so on. But I found myself in positions that were a bit outside of my comfort zone many times. So I decided, why not? Let's take a step up. And I joined an online retail company as a CTO in St. Just d'Esvern. And I didn't like it that much. I thought management was not for me, so I wanted to take another step to the side and go back to the career path. So I emigrated to Sweden, and the idea was to build the infrastructure department at a small streaming company. At that time, very small. Emil Fredriksson, who is the mastermind of many technology aspects of that company, and most culture aspects of that company, the good ones, who was my first manager, promised me that that would be a very hands-on work. We wanted to be very techy and all these kind of things. It wasn't, but I loved it. And the gig lasted for 12 years until 2 years ago, when I was completely knackered, wasted, destroyed, burned out, all these kind of things, and I needed a break. So 2 weeks later, I joined another company. That was the longest career break I had had until that time. That was a perhaps bad decision in retrospect. Anyways, I came back to Barcelona, so I'm living here where I was born. And I started advising companies who wanted to scale. This was 2020, 2021, and so on, right? You have heard money was free at that time, so let's grow like there is no tomorrow. And obviously, many people didn't know how to do that, so they decided to ask for my helping hand. I learned a lot, but it was not my cup of tea either. A year and a bit ago, I became the CTO for a venture capital company in Girona, Segways. I had understood what it meant to start up companies. I had understood what it meant to track the wishes of investors from the execution side. I had not seen the world from the investment side. So at that company, I basically led all the technical due diligence processes, I did technology evaluations for companies where we were going to invest and companies where we are invested. And I've learned a lot. And actually, after having seen that world from the inside, I can tell you there's a lot of decisions based on something that resembles gambling more than science, but not because this is my company. I can tell you that there's different ways of doing that, and at Segways, there's some science behind what we did and reproducible processes and these kind of things. Anyways, until a week ago, I resigned, so I am building something new to help engineers and teams to be productive, but without all that bullshit that comes from corporations and the traditional language about productivity and so on. It's called DevTuner, and if you stay until the last slide, you might get a QR code to get early access whenever we launch, which will not be soon, I can tell you. Before going to the chapters, this is a story of some of my learning, some of my mistakes. You ignore what I say, make your own mistakes. But if you can remember a few things here, you might make those mistakes a bit less painful, or you can relate to some previous experience of someone else. So please use it with care. And perhaps this is something very, very, very important that many people seem to be not understanding. If you rename your teams to squads, you don't become the next Spotify. If you give unlimited vacation, you don't become the next Netflix. If you create OKRs in your processes, you don't become the next Google. Make your own mistakes. Cargo culting is perhaps one of the worst ways to make decisions. Use your own context and learn from experiences. Many of these processes have postmortems. Many of these ideas have literature behind them, so try to understand what you're adopting. So this is going to be a bit about, this talk is going to be about decisions. You might remember from the first slides that I believe that making the right decisions at the right time is really, really difficult. And in yellow, I'm going to highlight today a bunch of decisions that I believe could be good at the right time, even if they sound a bit exaggerated. So think carefully about your context. For instance, my alerting dashboard is all red. Let's double the infrastructure team. We're going to fix it that way, right? Well, this could be a solution given certain circumstances, given that you are like only 2 people dealing with an infrastructure of 5,000 servers. Perhaps that's the right thing to do. Or my alerting dashboard is all red. Go to the bottom of every single alert and remediate systemic problems. Well, that could be a good decision on the paper, or a very bad one. Your alerts might be bogus. You might be alerting on things that you don't even remember. Maybe the right decision in that case is like kill it all and start over. Now, onto the meaty part. We're going to talk about early stage. So you have an idea. You raised some money, or someone lent you some money, or you have some time to dedicate to that idea. You have not proved that idea. And you spend too much time on Hacker News reading what the latest trends are. Right? So, before building our MVP, let's do all these kind of things. Auto-scaling, why not? Continuous deployment, you name it, everything, right? For your non-existing user base. We've all made that mistake, different stages in different companies. Probably the situation comes from not understanding the concept of cost of opportunity. Cost of opportunity is all the things that you are not doing, like that MVP, instead of dedicating your energy to things that will not directly affect at least what you want to accomplish, which is validate a hypothesis. We are not talking about scaling something to 1 million. So attention is your most precious asset, in my opinion. And also, if I can be a bit snarky and a bit sarcastic, if in year 2000, most B2B, business-to-business services that we built were running on 2 or 3 Dell servers, 2024, compute capacity has increased substantially. We do a lot of cool things nowadays, and there's complicated ecosystems and so on. But I believe there is a way to remove early distractions in infrastructure. And if we spend too much time on Hacker News trying to imitate what others are doing, we might accidentally get a bit removed or disconnected from the problem we have at hand. This doesn't mean that you need to be completely careless and not give a shit about what you're doing. Like, you should ideally keep some sort of inventory or like list something of all the shortcuts you took, technology-wise, organizationally, all these kind of things. Because if you don't do that, and hopefully you succeed, in 2 years, you're going to hire someone, or you're going to have a real team that are going to be ranting all day long about technical debt, because they will lack the context on why those corners were cut at a given time. Also, very important, combine the traits. When you have a small team or when you're hiring a team, find people who combine the traits. You cannot have a team of pragmatic people only. Everything is going to be hacky. You cannot have a team of very deep technical people over-architecting everything from the get-go. You need to combine those traits. Ideally, in one person can have multiple of those traits, but they don't grow on trees. I'm seeing some that I really respect in the audience, so try to find those kind of people. When I moved to Sweden, I was amazed. So we were running an operations team and a backend infrastructure team doing roughly what we would call infrastructure, mostly backend at that time. We didn't think about other verticals as infrastructure, mistakenly. The backend infrastructure team was in charge of building all the plumbing, service discovery, backend to backend communication, user systems, multi-data center capabilities in the service layer, all these kind of things. A lot of complicated things all the time. 6 people. impressive. The operations team was deploying, running, being woken up at night, giving laptops to new employees that were starting every day, buying servers, scrambling to get spare capacity, all these kind of things, configuring BGP, all these kind of things. There were also 6 people. And there were, on top of everything, there were 20 important systems that needed to be up and running at all times. And those 20 systems had, each of them, more or less, an operations owner and a development owner. Everyone was busy. There were millions of monthly active users. And there were features being built at all times by other teams. And there was a lot of hiring ongoing. So there were a lot of interviews ongoing and a lot of growth pains associated to that. And we didn't have time to, we were not good systems thinkers. We were like super detail oriented and we could not zoom out. We were too naive, perhaps. Communication was broken. Backend infra, as an example, backend infra felt that they were constantly being interrupted by operations. Operations felt that they were being unheard by backend infra. Frustration was mounting. Things were not pretty. So we invented a very sciencey system to address this problem. So something is broken. Doesn't matter. You go and fetch one of those pink notes, you write what the problem is, and you stick it on my desk. And when I have time, I will look into it. Yay or nay? Quite naive. But there was a time when those things were much smaller, where perhaps that was a good yay, because people were in the same office, in the same floor, in the same building, sitting next to each other. But 20 systems that were constantly on fire with that amount of people, perhaps that system didn't scale well. This was a very good decision for a very short period of time, perhaps, if I may say. So how did we address this, or things that you can do to address when you encounter situations like this? Well, we hired people. If I can name someone who didn't have a technology background, Karin Björken, who had the right mindset and taught us to basically value other things than solving everything with a system, like communication, like being proactive about postmortems, all these things you've heard, but when you are like super zoomed into a problem, you don't even consider. We also learn, thanks to some other key hires, like Francesc Zacharias is a good example. He's from Barcelona. He could not be here today because he's traveling. You need good gardeners. You need a good balance between gardening and landscaping. You cannot be always landscaping or always gardening. But infrastructure is a bit like a plant. You cannot forget watering it. It will survive a few days. It will survive a few months. But it's not a long-term plan. So when you have the right gardeners in place, many things that are broken, like this broken glass syndrome or whatever it's called in English, it's a good example of something that gardeners can help addressing. So things keep growing. It happens in every company that gets successful. Triple figures in many dimensions and more than triple in many others, going from like a few thousand servers to 20,000 servers, going for 20 to 60 core systems, all these kind of things. We encountered those things. And in 1 year, despite the number of employees grew substantially, we could only hire one person for the operations team. You might remember that I said before we were an operations team that could do anything from BGP routes to data center procurement to everything. It was impossible to find. We were looking for unicorns that wanted to move to the cold Sweden. At that time, there were not many of those. Releasing things required a lot of effort. And we, by the way, we wrote a chapter in this book, so that explains those things in a more rigorous way that I'm doing today. So if you want to find it somewhere, probably you can easily get a copy. Releasing things require a lot of effort. So synchronization problems, let's put a person of each team in a room. I think I stole that picture from you, Blix. You might have taken that picture. So this is real. Yay or nay? Well, it was a big yay. We got a lot of shit done for a long while. But probably the point where there's no meeting rooms in the entire building that could host a fraction of those people is the point where this is a bad idea. So learnings or things that can help. We came up with this idea. No, we didn't come up with that idea. We copied an idea, actually. But we got inspired by others, which is something I recommend everyone to do. In this case, Pedro Kanawati, who was VP of production engineering at Facebook at the time, talked to us, and he explained clearly, word by word, which problems we would encounter if we didn't address that problem of like having central bottlenecks. And he was right in 99% of the cases, and he explained also all the things that he regretted that they had not done in time. So it was a good learning opportunity. So based on some of those talks and many others, and with a lot of effort inside the company, we distributed operational responsibility everywhere. We went from having one team on call to having every team on call. We went from having one team doing infra, some parts of infra, to having every team potentially building infrastructure. And there's the common thought that what you need to do is to make people feel the pain so things will get better. If there's downtime and you get woken up at night, you will fix your systems or components and so on. But I think the most important part of the way I experienced that was the second part. People all in a sudden felt a bit more unblocked with a lot of difficulties. This was not a walk in the park. This was complicated as hell. But many teams really removed some of the dependencies that they had to deal with every single day. With trust comes a lot of responsibility, however. So now, fast forward, now you have an infrastructure organization that has delegated all the operational responsibility. But there's this notion that infrastructure should, by the way, throughout the presentation, I've decided to use infrastructure because every company uses different naming. You call it as you wish, but when you have 100 people, you basically are at the size where you have problems that are difficult to distribute. And the first important questions start popping up, which is who owns the service being up? Who is responsible for the service being up? Most importantly, who owns the service being down? Tomorrow the service doesn't work, who do I call? How do we find which team has caused an issue? Who owns cross-cutting workflows, right? Provisioning, capacity planning, data center monitoring, all these kind of things. Who owns architecture, the A word? Who owns conventions, best practices, all these kind of things. And many others that you can come up with. Also, it's very difficult to talk about this openly without being perceived as a dinosaur. So that was personally one of the challenges, making people understand that the cross-cutting needs existed and making that visible without putting yourself in a I want to be the gatekeeper kind of role. because that's not the whole idea behind that. So yellow slide again. So you know what? Really doesn't matter. Every product team can own their own infrastructure, and we don't care about consistency, right? Well, it's a yay in many cases, but at that scale, perhaps that was a big nay that we didn't pay right away. We paid throughout, and I'm sure someone's still paying there. We paid throughout an extended period of time. So countermeasures to that, well, let's treat infrastructure as a product organization. Yes, those product organizations that we seem to like to joke about and we tend to dislike in many occasions, that was a good solution. That was a win that I didn't anticipate myself. So how do you go about that? Well, we basically physically traveled to every team, interviewed everyone in every team, very scalable. Tried to compile a list of the common issues that every team was facing. We factored out those problems that were common, those things that in the interviews were always present. You can imagine things like monitoring, storage, databases, all these kind of things. And once you have discovered those big clusters, create a product for each of those big clusters. All in a sudden, you have an infrastructure team that sends a monitoring product, so to say. It's not a real product, it's many, and obviously hybrid technologies, legacy technologies, evolving infrastructure doesn't make this a clear cut. But that was extremely successful. I'm going to say out of the 13 products we identified at that time, perhaps around 60% of those were highly successful. And then the rest were a bit of failure. That happens as well. And you staff those teams like as if you were staffing a feature team or something like that. Like hire PMs or like promote someone to PMs, everything. Like treat users as customers, like a real product, basically. And those teams should also be autonomous. So it's not okay to create a product team with an infrastructure that at the same time has like dependencies on everyone to get the job done. So the same principle around autonomy and letting people fly solo and feel the pain should apply here. It was more or less successful, or actually it was very successful, counterintuitively. So what happens next? Things start taking off for real. So something I discovered is that when you grow very quickly, there's a very thin line between doing capacity planning for services and having to wait for a construction company to build a building in the outskirts of London. For real. Some building had to be built to host a Hadoop cluster, as an example. And once that building is built, you need network, and not like home network. You need network, and you need power, a lot of power. So those things take time. The result of that, if you encounter yourself in that situation, and I know that nowadays no one does data centers and these kind of things, but I mean, I'm very old, so I get to speak about this. When you're in that business, you realize that a large percentage of your time is being wasted, and your energy and your backlogs and so on is being wasted in problems that are really far from the problem that you really wanted to solve, which is streaming. So, well, right? We were modern. So let's run compute in the cloud, and slowly, so no one gets very upset, slowly start porting every component away from the data center. Yay or nay? I don't know. For me, the slowly part is what makes me a bit uncomfortable. The cost of running hybrid systems, the cost of transitioning for an extended period of time is yet another of those opportunity costs issues that I described at the beginning. I'm happily reporting that we didn't do that. We went very quickly. We learned also again from others. We learned from Netflix, we learned from others, and we try to make it as quick as possible. And perhaps the lesson learned here, or the thing that I will keep in mind from this moment is if you have to do a big infrastructure shift because otherwise you will not survive, you bet. You bet on that. You bet for real on that. And if you don't dare to bet, you find some other solution. But don't make being prudent a reason for not betting. I've seen many companies that have had ongoing cloud migrations, as an example, for years. They actually start their second cloud migration before the first one is finished. Right? So it's if you keep things running in a very hybrid mode, it will be very costly for sure. Again, second identity crisis for infrastructure teams is brewing here, because now the threat is not inside, the threat is outside. There's the big G and the big A and the big other A building very big things that you cannot outcompete them. That's very real. That plus you are building on tech that is perceived as old-fashioned. No one enjoys that. New hires say, oh, but do you run this shit for service discovery? Still you do DNS for this shit? Have you heard about these modern things? These things are real. You start questioning your life, but those systems need to continue running, right? We're not talking about a lemonade stand here. We're talking about millions of users that need a service every day, every minute. At the same time, it doesn't make sense for all these people to keep replicating functionality that's in the cloud or wrapping APIs or abstracting the abstraction of the abstraction. This kind of doesn't make a lot of sense. A lot of questions around do I have a job? Start popping up. Or things like, I am stuck with this because there's technical debt and the old things need to continue running, but all the people who are doing the cool stuff are people working elsewhere. That's also real. So the identity crisis is very potentially impacting a lot the morale of teams and so on. So yellow slide again. You know what? We don't need them. We don't need them. We move people to different teams and they are very smart and they will help the team where they land. There's a big mistake happening in many companies, which is treating cloud providers as software outsourcing companies. Cloud providers are very good at hardware, commodity services, all these kind of things. You cannot compete against them, and you should not compete against them. You should not run your own storage something unless you have a very good reason to do so. Or compute. Are you going to be in the business of buying SSD drives? I don't think so. But decision makers can often think very naively about what a cloud provider is and oversimplify what they bring to the table. So it turns out infrastructure people know where you are hiding all your skeletons. That's something we are very good at. Probably we've hidden ourselves some of those skeletons, right? So those people with the right mindset, with the right motivation, with the right motivations and so on can be your best ambassadors for doing things that you have not been doing because you were building data centers. For instance, conventions, increasing the abstraction layer, identifying new product needs. Oh, there's these 5 teams that are actually dealing with a mobile pipeline with a data pipeline here, served to a backend service here, and they need to talk to 7 people to get the job done. Maybe raising the abstraction is someone who understands all that plumbing can facilitate. So I think this is the time where you start encoding best practices in the infrastructure layer. This is the time where you start modernizing your tech stack by removing decisions from the users of the infrastructure. And you can do that alongside the cloud providers. But you understand the value of software on top of commodity hardware, so to say. So, more identity crisis. So, do we really need to reinvent the wheel? So, now you're encoding those conventions all in a sudden in the software you build, right? And magic happens. Really, things get simpler. And the reason to keep that very old legacy system that is only used by 3 teams is no longer a strong one. Also, someone might think cloud providers have all these higher order primitives as well for free, right? Quote unquote. And also, if you build some of those components in-house, how the heck are you going to quantify how much they cost and what the benefit they provide? You know what? There's something that can be quantified. My Google Cloud invoice. So, pitfalls that can happen at this stage, obviously. One thing that happens as well is as you get adopting higher order primitives from the cloud providers, reasoning about failure domains becomes super complicated. All in a sudden, you can find yourself having like very weird incidents, and you don't know if the problem comes from, like, I don't know, Telefonica has a problem in their BGP, or Amazon has an availability zone being down, or Facebook logins are down and someone has connected the OAuth tokens somewhere. Failure domains get very complicated in this very cloudy world. And that's okay. We will get better at that, but that's a reality that you encounter at this stage. So, since we cannot make sense of this mess anymore and operating this thing at scale, and failure domains are getting more complicated, you know what we needed for real? We need to double the team again, or we need to make things much bigger, because then we will understand those problems better. Yay or nay? Well, depends on many things, right? Maybe if you're going to abstract some higher order primitives, it's a clear yay. But if what you're going to do is babysitting a console of an external provider, maybe the answer could be a nay. So one thing I've learned is I like this concept of the two-way door decisions. You can bet, as I said, I don't want to contradict my previous slide when I was talking about betting, but betting for real. But whenever you bet, make sure that you understand what's a two-way door decision and what's a one-way door decision. A two-way door decision is that one that will probably allow you to adopt a managed service provider safely, because data portability will not be an issue, because formats will not be an issue, because integration with external providers will not be an issue. A one-way door decision might be that one where you decide to adopt a managed service of sorts that all in a sudden spreads throughout the entire company. Many teams start adopting. And the day that someone increases the price of that service, or the day that someone decides to deprecate that service, you all in a sudden, you don't have a productivity problem. You have a I need to escape problem. Probably there's some governance required to that, and perhaps you need a well-represented team. I don't want to call it architecture team. But a team that owns those conventions, the way we reason around two-way door decisions or one-way ones. That team should be as far as possible from the traditional architecture team, because they tend to become gatekeepers. And that's perhaps what you don't want culturally in an organization. Obviously, every company is different. And I believe they should own not only like spreading the word, not only ensuring that everyone understands that word. Also, they should own like processes connected with that, such as how do we modernize in the future? How do we revert previous decisions? Like tools like owning a technology radar or things like that could be useful in those cases. We are reaching the last chapter now. So some things that can happen, I hinted at those before. We don't own infra anymore. Everything is commoditized, right? We don't run infra. We have forgotten how to build infra. When people build infra, they might do it not very openly. Building infra can be frowned upon as working in very low variance problems. And I've seen the table from both sides, and I think that's right in many cases. But I think we lack like some of the naive approach we had like 10, 15 years ago to building infrastructure. So things that could happen, right? Multi-cloud will solve all my problems. We talked about hybrid systems before, like multi-cloud might be a very valid solution, a valid decision, given some things. If you're using very commoditized low-level primitives such as storage or compute, that could be a very good decision. But that's rarely the case when this idea comes to the table at this stage. Anyways, my message is you should be able to build infrastructure at every stage of a company, but you should pick your battles very, very clearly. You should have some criteria to decide when something is worth tackling and when something is not worth tackling. So there's a use case very like unevenly distributed, only a few teams needed. Don't platformize anything there. Let it burn, let it fail, whatever. Things will migrate towards a more blessed stack eventually. There's a service used more or less consistently across a large organization, a large group of people. Well, you can save a lot of money if you platformize at the right level. A lot of money. Do not forget that one of the reasons why cloud providers can offer the prices they offer with storage and compute and so on, it's not only because they buy hardware in the millions of servers at a time. It's also because some of the higher order primitives they sell come with an extra cost. Right. So the summary is there is one right moment for almost every infrastructure decision, every investment, every technology decision in general. And there are many wrong moments. But you're going to get it wrong. And that's fine. I think my thesis here is that most of the things we use and we love to use every day have happened because there was someone crazy enough to make one of those decisions at the very obviously wrong time. So I don't want to invalidate my entire talk with this slide, but think that mistakes are rarely the end of the world in technology. So 2 closing remarks. You thought you were coming to a presentation where the word AI would not come up? Well, you were wrong. I think we have a very interesting challenge ahead of us, infrastructure people. I think the way we've been running things for many years has been the real-time way. We've been optimizing the heck out of our messaging system, microservices, Kubernetes, compute, orchestration, all these kind of things. We've optimized the real-time runtimes a lot. And we've done fairly okay. I think there's some work to be done, right? But doesn't matter. We've done fairly okay here. But there's one thing that is coming back, because this is not the first time we go through that cycle. I think compute is becoming more and more batch. And in the world of batch computing, there's a lot of legacy and a lot of work to be done. And we have treasured a huge amount of knowledge around reproducible builds, around like testability, around continuous integration, things that were not done in 2005 that much. So we've treasured a lot of knowledge. But I mean with this is a very optimistic take. And I truly believe we have a lot to bring to the table of doing the right things in this new batch computing wave that is coming. The reason why the batch computing wave is coming is because even if we are doing things that we could not do before, many of the big processes behind like AI models and things like that require like asynchronous training, things that cannot be done real time, things that will require you to ingest a ton of data and process a lot of data and fine tune a lot of data and retrain a lot of data. All these kind of things are coming. So I think we have an opportunity to bring to the table some of our learnings in the real-time world into the not so real-time world. And I think the batch computing has a lot of technical debt still, or a lot of things to be improved. So I think bottom line, we will continue having a job, and a very fun one, because we will get another greenfield-like scenario, which we really like a lot. But it will require us to escape a bit the comfort zone, I believe. But if you have been in tech for a few years, you've already done this twice at the very least. Like you saw the internet, you saw, I don't know, cloud, you saw mobile devices. All these kind of things have changed how we build infrastructure. And we've learned in each of those steps. And now the very closing one, I saw a tweet the other day that made me a bit, I could relate a lot to this person. So someone who escapes, I understand like the craze of the software industry that we are in and like the high-tech industry we're in. Someone who goes a bit zen and works in a real world company. I'm a bit jealous of this person. Obviously, it's not a very beautiful thing to do sometimes, and you have to go through a lot of shit if you go to a more analog world. But my reflection is, sometimes we make things much bigger than they need to be. I often feel that I was having more fun and more joy in my 6-person, very stressed out team putting out fires, because things were happening, and we have like covered everything with a lot of rituals and complexities and so on, not only in the technology front, obviously. And sometimes we make things more complicated than it should be. So I think it's part of our responsibility as infrastructure people to be able to kill our darlings and show that there's ways to simplify things and so on. And obviously, I don't want to underestimate the different scale of the problems we're tackling nowadays in technology, which is very certainly orders of magnitude bigger in many dimensions. So this is it. I think we have 5 minutes for questions or something. 10? Okay. But as I promised, the DevTuner thingy, right, fill out that form if you want to know about DevTuner at some point. That's it. Questions? So someone prefers to ask in Catalan or Spanish, let me know and we'll translate.
Yeah, okay. Thank you for your presentation. I have a question regarding did you try infrastructure as a service for your infra team? Yeah, because right now, you're right. Yeah, clouds are really expensive. Yeah, and you need to. I don't know if you will. If you have a data center, yeah, you need also network engineers, database engineers, Kafka engineers, for example, yeah, and et cetera, et cetera. Did you try this approach, infrastructure as a service, for your infra team? Yeah, because it's a really working solution, and I know big companies really like it, and it works.
It does work. In some of my previous work experiences, it's been tried almost everywhere to different degrees. In the particular example of Spotify, there were several attempts and actually some infrastructure working with basically more platformized version of our data centers and so on. But I think there was one thing that dominated everything. When you have like, I don't remember the figures, so don't quote me on this, but like 25,000 servers. Like sending a person to replace hard drives once a week is not enough to replace all the hard drives that are breaking. So there was like something that really didn't scale, having the underlying infrastructure powered by servers. Then infrastructure as a service, as a way to abstract things like multi-cloud and things like that, that could work, and it's also been tried. And to some extent, some of the tools that some companies at this level have are that, and Spotify as well. But those abstractions are sometimes very leaky, and they come with like very legacy systems that do not adhere very well to that primitive and so on. So I'm going to say that there's like a bit of an infrastructure as a service layer mindset as well, but it requires going all in that direction. It's not like a trivial thing, or at least maybe we could not do it better, basically, with the resources we had at the time. Ignacio?
Yeah, hi, thank you for your talk. So I have a question. I have the feeling that the journey that you have been describing is going between two, I'm not sure if call them worlds. One is the technical world with the developers, the infrastructure, the systems, the everything, the cloud, and the business world about taking decisions, about investments, about cost of opportunity. How much would you say that each world had been part of the problems or part of the pushes, how much they had been pushing for a specific decision through this journey?
I think there's I don't see it as like two different worlds, but you're right in your observation that I've been navigating those two sides of the table, as I said before. I don't see it so much as like a problem of two worlds making or influencing decisions. I see it more as a problem of like conflicting incentives leading to different decisions. And honestly, like some of the biggest battles I had to fight in my career have been like with different technology teams not agreeing in a way forward. So I'm not saying that the business is always aligned with the ideas that the teams have and so on. That's totally true. But I think the problem is like alignment at another level. And I think you need to have an organization that understands, all right, this is what we are optimizing for. And this is where we want to go. And all right, I don't agree in this sequencing of work, but I'll be fine. I'll be fine taking this path for a while. Like it's more like a negotiation of conflicting incentives, and it's certainly not two parties. It's like multi-party, and sometimes impacting external providers that you have committed to a certain launch date or an integration with an external service or something like that. So it gets complicated. But I think it's like having misaligned goals or incentives or something like that. What the source of the problem, and it's difficult to navigate, and it can be soul draining. And that's certainly something that when things are smaller, it's a bit nicer. All right. Thank you so much.
There is no break for this poor people.
Do you want to have a break, like 2-5 minutes? Going to toilet maybe? Or no?
A veure, penso com va això. Sí? No. No sé, hòstia, ara. Ara? Sí?
Contraintuitiu.
Ara sí o no? Ara sí, ara sí, ara sí.
Hi. We're about to start again.
Yeah.
Okay.
Okay.
Yeah. Go.
Okay. Well, thank you very much for Adevinta for letting me speak about this playground environments. This is how I call them, playground environments. Yesterday I was looking around, and they are called feature environments in some places. So, and this is a story that started many years ago with Enric, that is also here. And well, let's go with it. So first, let me talk a little bit about me, about my background. I started to code the last century in 1999. It was 1998. It was 1999. I one of the founders of Texma. It's a software company in the very boring landscape of industrial B2B software. Later on, I was doing some freelancing for some English companies, Tesco, ABI, and Mumbai. And finally, I took the lead at Circuiteur, another boring industrial company that does electricity protection, capacitor banks, and all these kind of boring electrical things. And they asked me to lead their cloud product. And I must confess that I'm not one of you. So I'm a developer. I'm not a DevOps or system administrator. I'm a developer obsessed with automation. Okay, obsessed with products and automation. And well, let's start. So what I think it's a playground environment. A playground environment is a preview environment that you have for each merge request or pull request. Okay, this is a journey that started many years ago when I was building a product that was a Telegram bot, and I needed to play with Telegram bots. And the thing is that at that time, the right way for Telegram servers to send data to your bot, it was through webhooks. And the only way to play with new features was having a real server working somewhere else. So this is where I was working with, Enric was helping me with this. And in fact, we find a way to deploy for specific merge, for specific branches using tags. We were deploying an entire ECS cluster at that moment. Because we have many credits. You said that money was free. In fact, I got 10,000 euros to spend in Amazon infrastructure. That's the worst thing that ever can happen to a company, to have free money to spend on Amazon. It's then you end up like bloated with a very big infrastructure because it was free. So the thing is that this was 2018, 2019, and that one at that moment that was a very primitive way of doing these environments. And at Circuiteur, when I came into the project, I had a very ugly structure with a Java server for IoT things, like 7 Go microservices, an Angular front end, and it was very hard for the developers to see that everything was working on. So I came up with the idea of building those playground environments. So what is a playground environment? It's a preview environment for each merge request with its own front end, with its own backend, with its own database that is destroyed at merge. Okay? So that means it's a very short-lived entire environment. This is destroyed at merge. This is false. I will tell you later, because it never works. So let me show you a very quick demo. Oops. Tripping. So those are the merge requests open right now in my team. And for example, just pick one of the merge requests. For example, this can be done, for example, by the product manager. For example, this is a way that the product manager, the QA team, or the product designer can check the work of the developers very easily. And at the end, this is with GitLab. You have a link that says view up. And you can see this is the merge request that closes 1,199. And this is play 1,199, fix assistance, whatever. And here I can sign up. Oops. And say, who's going to receive the mail? Well, we have an inbox where we see all the emails that are sent in this environment. If we wait a little bit, we have the link with activate account. And now I have a fresh version of the product. Where I can play, create projects, upload data, whatever. Okay, so I'm going to tell you step by step how you can build this at home. First, don't try this if you don't have an experienced ops team behind, because it's just, in our case, what we have now, it took us almost a year of building. Of course, many iterations, many refinements, but let's go straight to. So why would you want a playground environment? First, because it's easier to do quick reviews, especially for the products team and the designers. It's very easy. It's a very easy way to run isolated end-to-end tests. Then you can use it for run, for example, load tests, and then it increases the team collaboration. It has some advantages. It has quicker functional review times. It enables developer to see, for example, for the front-end guys, lets them play without setting up an API. For the back-end guys, lets them play without having a front-end. Okay. And they can be used for many things, for debugging, load testing, mobile. For example, for hardware integrations, what we do is when the firmware developer has a new version of their firmware, we spin up a playground, then they point the hardware device to the playground environments, and then, for example, if we need to make some adjustment on the APIs or whatever, or the MQTT protocol, it's much more easier, and productivity it's better. It has some disadvantages. First is cost. They are very expensive. It's a whole system. That means if you use Python, for example, we have very big images, it's going to be memory hungry. It also means that developers tend to rely too much on them. And it's like, oh, why should I spin up a local environment if I can just push it and put it in the playground? And then I wait for, now we have a build time between 10 to 15 minutes. But and another disadvantage is a delighter that defines your whole architecture. And this will come later. And this is one of the things that if you start this way, if you start doing playground environments, then everything you do, you have to think that you have to deploy it using this way. Because if not, what will have? A playground environment without this part of the system. How will you recreate it? And then the cost. It's expensive. Okay. In our case, you need a Kubernetes cluster. And you will see that for example, for TCP protocols, you need a load balancer, or you need to do some magic, black magic. So the recipe, it's you need a Kubernetes cluster with an ingress controller. You need also Helm, and you need a GitLab monorepo. In our case, we have, I think it's 6 components. Our architecture is based on 6 components, and we have everything on the same repository. That means that we have a single commit and a single version. So we have a single tag and a single version for each commit for across the services. That makes much more easier to deploy them all together. Okay, and lots of refinement. Okay, I think that there are some commercial products to build this kind of playground environments. I didn't try them, but in our case, we build by ourselves, and it needs a lot of requirements. And from a developer's perspective, sometimes it involves some kind of black magic, or like sacrificing a goat, because you need to do something that are on the edge. Okay, so let's go. This is our application. We have, so for example, I said that they are memory hungry. We use Go. That means that our service use 20, 30, 40 megabytes when they are still, when they don't have load, they use very low memory. For example, we have I think it's 3 services in Go, which they don't use a lot of memory when they are still. But we have a background job for doing some reports and some machine learning. It is in Python, but this one it's 200 megas, or so it's much bigger. And then we have a Postgres database and a Redis database. And then we have an Angular frontend, which is the former frontend, and nobody in the team wants to get inside and put it away. And so we started building new things, as every team does. And finally, we have the load balancer. One important thing here is that this doesn't happen in many places, but we have hardware devices, physical hardware devices, that send information using all legacy protocols like FTP and MQTT. Okay, for example, we have a device that we send thousands of them, that it's sending data through FTP and XML. Okay, we'll never lose a job. So the thing is that, for example, for the HTTP, we have a load balancer, an ingress controller, but what we do with the FTP and the MQTT? If we want to use the same port, it's 25 or 21, and it's MQTT, it's 1883, we need an entire load balancer. Okay, for production is okay, because we have one load balancer for production for those fancy protocols. But for the playgrounds, what we're gonna do? We're gonna have a load balancer spin up each time that we have a playground. We'll see that there's some alternative. So how do you create a playground environment? So playground environment mainly is the same application deployed many times, very standardized. So when you create, so you prepare your application for being deployed like that, is you have to make sure that the application it's very configurable, and that you can deploy it many times using different configuration. So we have the ingress with host-based routing that sends the request to each of the environments deployed. Okay, and then we have the same Postgres SQL server, the same Redis servers, but one different database for each one of the playgrounds. That means that everything you spin up for each deployment, you need to spin it down when you're done with your job. And for some cases, we have an FTP or MQTT load balancer enabled to send traffic to here. So for example, for some hardware integration, we need to spin up the load balancer. So here you see this is from some minutes ago, some hours ago. For example, here you have all the applications deployed here. You see all of those, each one of these. It's this application for issue 1160, and then for each deployment you have all the pods. Look that it's very important when you design the Helm and the template that everything is configured, because you will have like tenths of pods, of the same pods, but with different namings. Okay, it's very easy because when you're working on an issue, it's very likely that you remember the name of the issue, the number of the issue, and then it's very easy to see the pods. And then you can, and then if you need to if you need to check the log, for example, imagine you're deploying a new feature that has some involvement of the FTP server, the API, then you can connect with the port forwarder to the FTP server in localhost, you upload the file, and then you can see the log, for example. It's very easy. For developers, it's very easy. So let's gonna go step by step in deploying how to deploy a playground environment. First of all, the tags of the Docker images, we've done it with the branch image and the commit hash. That means that we have built for each branch and each commit. Also, remember to clean. And also, when we merge to main, we tag also main with the commit hash as a stable. Then we always have a version, because the first time we deploy a playground, we only build the image for those services that have been modified. And for the rest, we use a stable. And a very important thing, everything needs to be defined at runtime. So you cannot have any configuration inside your software. Any kind of configuration. Because, for example, any of you is familiar with how React of Angular pack their applications? They have a .m file inside the Docker image. That's not possible, because you have to do it at runtime. Because the same Docker image that will run on a playground will be in production. So you have to find a way to define everything in production. In runtime. Or for example, imagine you have Sentry. Okay, Sentry that is sending the exceptions. You have to send them when you configure Sentry. You have to configure the environment at runtime, because then when you look at the exceptions sent by Sentry, you can differentiate them by environment. Okay, so this is the hardest thing to do. So we define some pre-existing variables, which is dev Postgres and dev Redis, which are the base, the servers, the Redis and Postgres servers, and then you need this variable is provided by the CI/CD system. In our case, it's GitLab. But yesterday I was trying to replicate this presentation in GitHub and was GitHub ref name. And then the next thing is I define the name of the environment. I use the first 25 characters of the name of the issue, because in Kubernetes there are some length limitations on the port names in some places, though that means that you have to remove the characters. We use the name of the issue just for as a reminder, but because it's a play 29 with the name of the issue, it's much more easy to remember than play 29, but you can use play 29. And then also you cannot use hyphens in Postgres. You have to use underscores for the name of the variable, of the tables, of the databases. So I define the Postgres URI, the Redis URI. For example, for Redis, database, so the name of the database, it's the name of the environment. So also play 29, the name of the branch. But for Redis, this is not the case, because in Redis, databases are numbered. So we use the number of the issue. That means that if someone creates an issue and if someone creates a branch and creates a merge request, the whole thing fails because there is no integer, there is not a number to build the Redis database. But also, that means that by default, Redis doesn't let you have more than, I don't remember the number of databases. You have to make a configuration to ensure that Redis will let you build this 1,200 database. And finally, I set up the hostname. For the hostname, I will tell you later, but we use also the name of the environment .p.mycircuitor.com. Okay. Then you create a database with this very simple script. It just creates a database. Also, you need to make the deploy script to be say it's deterministic. It's that you need to be able to run it many times on the same environment. The first time, and then each time there is a push. So that means that, for example, if you create the database, you should check first if the database exists. Then we use Goose for the database migration, because you need to set up the schema again for each migration. And finally, we have a very small script with some test data, with some test users and some test data that it's ready. So in all Playground environments, we know that there is a user which is named userqa@circuitor.com with password 111. Okay, so we need to set up an entire database. First, you need to define the tags that will be defined on the Helm for each container. For each container, we're using YQ, which is the same as JQ, but for YAML. But for me, it's so this is very hard for me to program those expressions. But then you need to collect. So every time you build a Docker image, you pass a parameter to the next job to indicate that there is a new tag to be deployed for this environment. Okay, and this is the preference. We have default values for this Helm, Playground values so generic Playground values. So for example, we don't create an S3 bucket for each Playground environment, but being puristically, you would need to create an S3 bucket for each Playground environment. So what we do is you use the same bucket. Okay. And finally, we mix all those files, saying which ones have new tags into a new file that finally it's used here. So first is the default value, then the Playground values, and finally the tag values. As you can see, also Helm upgrade, Playground environment, this is the name. This prefix is used in all the Helms, in all the templates. Everything has this prefix. Okay. And finally, we pass some things that should be passed for each Playground environment, which is the host name, the environment, the URL, the database, and the database. Okay. And finally, we just put some description. The end-to-end test, we're not in a QA conference, so you just pass the end-to-end test. And finally, you make a very complicated script to first detect that the push is for a merge, and then destroy the Helm, the Postgres database, the Redis database, and whatever things you have built. But it doesn't work. So we end up with just a script that is run daily and looks for Helms installed, for databases created, and we check with the GitLab API if the issue is still open. Because, for example, what happens if an issue is closed, not merged, that the environment still is floating around? Okay, so after creating this very complex script, we just have a script that once a day, it just cleans everything, and that's all. Okay, so this is the overall. And now I'm going to go through very specific tips and tricks that if you want to build this at home, you will find those problems. So I'm saving you 1 year of your life. Okay. So first of all, the ID of the issue, it's very important. Okay, this is the ID you should use everywhere. Everything should be based on this ID: databases, environments, buckets, whatever. Okay, and we use the first characters for the issue for simplicity. But what happened? First, we used the 40. Then we found out. Then someone created a new template that instead of MQTT port was named Epi Backend Angular port, and then the sum of the characters was was beyond the maximum of what Kubernetes allowed. So now at 25, if someone writes a longer name of a port, it will break. Okay, then email. What we do is we created a very small email viewer. We use a Postmark sandbox to send all the emailing programs. That means that, for example, in a playground environment, we can test like reports, or we can, for example, we are able, for example, to load production data and then see if on Mondays, hundreds of reports are sent. Okay, and if we fix the problem, we just check this mail viewer and see here there the mails. So what we do is also when we send a mail, we attach a metadata with the environment so we can filter the mails back then. Okay. As I said, starting to do this defines a lot of things in your architecture. Okay. Also, environment variables. As I said, everything should be defined at runtime. This is very easy for Python and Go, but for example, for Angular, you need, you're more proficient than me in Bash. So we have a template, and when the Docker container starts, we just change, we make a substitution. The environment variables, we change this file into a M file that it's loaded in the HTML directory. And then in Angular, the first thing we do is load this file. Then we have environment variables with Angular at runtime. For Next.js, it's not so easy because you have to run a script that looks for a specific, but because what Next does is just takes your placeholder value and puts it everywhere in your code. So what we have to do is track the whole code and find those placeholders and change it for the value of the environment variable. This is at runtime. Though this script is run when the Docker container starts. Okay. Next, domains. At the beginning, we had just a private load balancer, and then all the asterisk.p.mycircuitor.com pointed at that load balancer. Okay, but there were some times, for example, when we wanted to show some playground environments to customers, and then it was not possible because they were not in the VPN. So our DevOps team ended up configuring everything, synchronizing Cloudflare DNS and Let's Encrypt certificate management. So when a new playground environment is created, we have a flag, for example, to make this environment public. And if it's public, the DNS gets updated. It points to the public load balancer, so we can share, for example, we can use it, for example, for hardware that is outside the VPN and for people that it's outside the VPN. Okay. But all the environment playground environments are private, of course. Regarding a database, keep in mind that each playground environment can have a lot of connection to the same database. And you cannot use connection pullers because connection pullers, at least in our provider, in the infrastructure provider, are defined per database. So you will need to create a connection puller for each server, for each database, etc. So it's very important that you clean the databases because you end up with a lot of databases in the same server. We create a very small subset of data because if not, every time QA or product team needs to check that something, they need to sign up, create a user, create a building, upload some data, okay? And also what we have is we have a GitLab job to put the production database into the playground or a subset of production into playground. Okay, this sounds very, it makes very easy to check that production things can be tested in playground environments without touching production. Okay, regarding cost, as I said, they are very expensive and also they depend on your technology stack. We just Go, we can afford it. Okay, for example, this is the next server. It uses, I think it's 50 mega. No, it's 100 something, and the Python job uses 200 megabytes. If you have microservices in Python, which honestly they cannot be called microservices in Python, you can end up with each environment. For example, right now, or the memory footprint of each environment is 240 megabytes. Okay, it depends how much you will pay. Of course, I see this as a way to improve the productivity of my team. So, in fact, I think that for me, this Kubernetes use case, it's okay. Running a Kubernetes infrastructure is expensive, yeah, but you share it by the number of developers, and it's not so expensive if they can play and if they are much more productive. And also for TCP-based services, as I said, TCP services cannot be routed using, for example, the Nginx controller, Nginx ingress controller, like because they don't have the hostname header. So right now, what we do is we have created a load balancer. So in the playground environments, the FTP and MQTT load balancer is only created if a flag is activated. So by default, it is not activated. If the developer wants to activate this load balancer, just the Helm upgrade, the playground, set flag expose broker to true. And then the broker is exposed. But I find out that with Kong ingress controller, you can make host routing for TCP services using the SNE header. Okay, I tried, it works. We are not using it but what happens this is with Kong ingress controller. We use Nginx ingress controller. To make this change, we need to change the ingress, blah, 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 blah. But I tried it in another project and it worked like perfectly. Okay, but also this only works for TCP protocols that you want to expose using SSL. But for example, I was playing with this example. I wanted to expose a regular email service at port 25. You cannot do it because it's a TCP protocol, TC alt protocol. And also, right now, we want our devices to start sending data using Stomp, and we will use Rabbit. Rabbit with a custom layer HTTP authentication, with a custom HTTP authentication layer. But what happens? I'm going to put a Rabbit MQ server for each of the playground environments? No. So for example, what we will do here, we will deploy this in the next month. But what we will do here is we will create a reverse proxy that using the virtual host query parameter on Rabbit. So for example, because Rabbit pulls this API to know if a user has a resource has permissions to use a resource. So we will use a reverse proxy to use this value to point to one of the APIs of the environment, because if we have a playground environment, each one has their own users, their credentials, etc. So with only one rabbit, we will be able to have many playgrounds, all in the same. Also, RabbitMQ lets you partition your Rabbit server into virtual host. Of course. Okay. Also, if you use services that are not allowed to be managed, you should find a way, for example, prefixes, whatever. Okay. And that's all. Thank you so much for your attention. And if you have any doubt now, and you want you have some specific questions, I will ask the organizers to stop the recording so I can show you the real source code that is behind this thing. But only if you have questions about specific parts of the